This is Jeff Mucci with RCR Wireless News. Thank you for joining us today for Coders. The question of the day is web scale reliability versus carrier grade 5.9's reliability. And today we got two seasoned veterans from the industry that are going to join us for a lively discussion on carrier grade code.
Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
Our first guest is Dr. Dave Ratner, who is joining us from sunny Northern California in San Jose. I think it's 68 degrees there, while we're suffering through bitter cold here in Austin, Texas. I think it's 35. Dave Ratner has been in the industry for quite a long time. We met several years ago when he was CEO of Open Wave Messaging. He has a PhD and master's in computer science from UCLA. He has an undergrad degree in computer science from Cornell and mathematics, actually computer science and mathematics. His PhD thesis was named ROAM, a scalable replication system for mobile and distributed computing. It's a lot of words, but I think it hits squarely on what we're going to talk about today. David, thank you for joining us this morning.
Hey, thank you for having me, Jeff.
Our next guest is Brad Nicholas, who has worked with Dave in past lives. He's a product management executive and has a particular expertise in today's smart connected products. He has an electrical engineering degree from Georgia Tech, an MBA from Michigan. He's worked at several broadband and mobile service providers, and now is, I think, in stealth mode, which you'll talk about in just a minute, around IoT. Brad, thanks for joining us from Chicago. What's the temperature in Chicago today?
You know, it's single digits. Appreciate the invite. Looking forward to the chat here.
Well, let's dive right in, starting with David. And why don't we start with your definition of carrier grade 5.9 reliability?
Sure. So thank you for having me, Jeff. You know, the topic of 5.9s is an interesting one. The basic definition is around 5.9s, or however many nines you have, is the percentage of availability or uptime. And so a 5.9 system needs to have less than 5.26 minutes of downtime in a given year. Now, originally that was defined to exclude maintenance windows. And so this was really only unplanned downtime. So lately what I've been referring to is what I call true 5.9s, or 5.9s availability including maintenance windows, because increasingly in today's mobile world and interconnected world, you can't be down every day from 1 a.m. to 3 a.m. or whatever your maintenance window is. And so 5.9s today really refers to what I call true 5.9s, which is no more than 5.26 minutes of downtime a year for any reason. And the interesting thing about the mobile operators and the global carriers is oftentimes they have real regulations and real metrics that they're forced to hit. In Japan, for instance, anytime there's downtime, the operators have to report that to the national government, and it gets published in a report. These guys are forced to make sure that their systems are absolutely bulletproof, that they don't need to take maintenance windows that impact downtime, that they never have to have human systems required in order to do changeover, in order to do failover, that they can absolutely guarantee that they can run their infrastructure and their systems with less than 5 minutes of downtime a year for any reason.
Mm-hmm. And Brad, let's jump over to you and talk a little bit about web scale reliability. You know, in the last 5 to 10 years, you've seen Google and Facebook and Twitter that are supporting hundreds of millions of subscribers. And, you know, talk to me about web scale, what it's like to run a web scale organization.
You know, it's really about a software focus. It's about commoditization of the underlying hardware that's being utilized. The software focus, basically these guys will build, design whatever code is needed to achieve the scalability and reliability goals that they're looking for. And then they go on, and most of them go out and open source the stuff that they create. So you've seen over the years, you know, Google obviously built internally their MapReduce infrastructure to really achieve massive scalability on the back end, on the data tier. Paper was published, and then you know, and then Hadoop, Cassandra, and all these other you know, database technologies were released to the general public. And there are many examples of that at all levels of the web infrastructure that you need out here to achieve scale. And the results are pretty obvious to anybody who opens up a browser. Facebook is out there with 1.4 billion plus users. About half of them are mobile now. None of these folks, use telecom approaches to achieve that level of performance. And it's not just web apps that people are clicking on with browsers. It's also real-time streaming applications. Netflix, Spotify are the obvious examples there.
Mm-hmm. Well, let's jumping back to you, Dave. You built, I think, one of the largest messaging systems at the time you built it for a Japanese operator. Can you maybe share with us the architecture and how that system was built and some of the inputs and outputs and some of the factors that impacted the reliability?
Yeah, so I have built some of the world's largest messaging and communication platforms going into carriers, specifically in Japan, but elsewhere as well. The big focus is on testing and reliability going into that to make sure that when they launch it in production, they can actually achieve that true 5.9 scale. I wouldn't necessarily use the word conservative, but I would say that the operators themselves are very gun shy about making mistakes because of the impact of reliability issues on not just their service, but their company in general. And so a significant amount of testing goes in, a significant amount of architecture review goes in, a significant amount of deep dive into even the programming languages that are being used, the coding approach that's being used, the approach towards quality assurance, testing in multiple labs before launching it in production. And all of this is aimed at achieving a state whereby they do not have to have fast follow patches. They do not have to have, constant operations, changing out the software, changing out the infrastructure, making networking changes and others. That they really focus on let's test it thoroughly ahead of time. Let's make sure we understand how to achieve a true 5.9s with this solution. Let's make sure that it can do that. And then let's launch it in production.
Okay. Well, before we fast forward to today's, web type platforms, why don't you maybe give us an overview of the server architecture? And you mentioned software development languages. Talk about that architecture that you use building messaging platforms, or even the last 5-10 years ago. What did those architectures and server platforms look like?
Sure. So most of the time on the architecture side, software was split into multiple functions or multiple layers, and the focus from the operator was always how you achieve true 5.9s and how you achieve that reliability at each layer. And so layers would be defined either as stateless, where it didn't matter which component you used, you just needed to get to one, and so you can use a traditional DNS round robin or other approach to ensure a load balancing approach to ensure that you find an available service. Mm-hmm. And then the contrast was there are other services that were stateful, whereby you needed to employ heavy HA models in order to ensure that if one went down, you could bring another copy up to serve the same purpose. Increasingly, operators have been focused on how they move away from traditional stateful models and how they get everything into a stateless architecture with, distributed databases today, like Cassandra and Hadoop and other kind of technologies, to maximize their ability to remove maintenance windows and really operate at a true 5.9s scale. Again, I wouldn't necessarily use the word conservative, but carriers like proven solutions. They like figuring out a model that works for them and then keeping with that model. And most of the code that's running that we've been using to develop these kinds of solutions in the past has been C, C++, and Java. They don't use Python. They don't use JavaScript. They don't use Ruby on Rails. They don't use some of these other kinds of techniques. They like their tried and true methodologies, whereby oftentimes agile as a development methodology might be used as part of the development of the of the process and of the program. They like what I will refer to as a traditional waterfall model at the end to heavily, thoroughly QA everything, to ensure that there are no mistakes, to ensure that it really does run at true 5.9s, to ensure that they don't need to use an agile methodology to do a fast follow patch the next day and the day after that and the day after that.
Yeah. Well, we use a lot of Google services, and it seems like they've always got a beta version. So if you talk about the telcos being on one end of conservatism, it seems as though some of these new emerging communications companies, and I consider Google with Google Talk, and I consider Microsoft having bought Skype, and you've got, I guess, Facebook with WhatsApp. All these guys are in the communication service businesses. They're just doing it through an IP platform. So, Brad, jumping over to you, maybe you could compare and contrast what Dave shared with us about a traditional telco background with these emerging communication service providers, the over-the-top service providers, in terms of their architecture, the types of software development programming they're using, and just what's their approach to the market?
Sure. Well, Dave's done a great job of explaining the focus on resiliency, right? And this whole notion of end-tier architecture for web scale apps. I mean, this has been around quite a while. When Dave was deploying those messaging platforms, I was out there with him, pitching them, and as a product manager guy doing all that. And we had end-tier when we've had it for many years. Same thing still applies. It's really kind of M+1 at each one of those layers. The more ends you have, the less vulnerability the service has to a particular element in that cluster going down, right? When they go and do an update, they can take one server out at a time, update it, and then move on without taking a service out of commission. I think that's pretty much the way things go across the board. The difference now is we're talking orders of magnitude larger scale from a lot of the systems that we have out there. The cost of doing something like that is ridiculously low to kind of turn it up, right? You don't need to actually put out physical metal anymore. You just sign up for a web service, a cloud service, and you're off and running. And then you can elastically scale that to whatever you need. So the real focus is on scalability for these guys. In terms of languages used and stuff, the world's moved a bit. I mean, computing's moved to the edge. Everybody's running around with smartphones with massive computing capability and broadband connectivity. So you see the server side moving more to serving APIs as opposed to serving UI. So all of that's being pushed out to the edge of it. And if you're focused only on the API part of it, you can start optimizing kind of the computer science approach that you're using to each of these nodes to build it exactly the way you want. So you are seeing specialized languages come in and being applied in these cases. And it really comes down to the development team making those decisions. And I'll give you an example. Let's say you've got a very JavaScript client heavy type app and you need a server element to it. And there's a lot of folks using Node on the server side, which is based on the Chrome JavaScript VM to actually run the server app. Now, a server guy will sit down and look at that and probably be horrified by the approach that's being taken to it, because it's very difficult to isolate a specific instance in there when you're running this thing at scale. But it works for the guys that have designed those apps. And I wouldn't suggest that the decisions they make, apply to everybody, but certainly there's room for alternative approaches. And as long as they achieve the scale requirements of the service, they're achieving success.
Well, yesterday was a big day for net neutrality and increased regulation on the carriers. So I'm still hearing a lot of clapping and roaring and people in the streets in Silicon Valley because the over-the-top guys feel like they've had a big victory, and the telco guys are saying, wait a minute, we just invested, billions and billions of dollars in this fast network, and everybody gets a free ride. So I kind of got this East Coast, West Coast thing going, where you got traditional telcos from the East and Silicon Valley in the West, but in the middle, with over the top and machine to machine and Internet of Things, where are these two groups coming together? Either one of you, open kind of, how are they connecting their networks together?
Wow. That's a big topic. Probably need another session just to cover it in depth, right? I would say, first of all, that they've taken some options away from the folks that own the network infrastructure. They can't monetize it the way they want to, simply because of the supposed democratic issues around access. When you have broadband providers deciding the rules under which you get access to content and services, that makes folks fundamentally nervous. And that's a great democracy kind of pitch, but it's also a bit disingenuous on the part of the folks that don't own the network infrastructure, especially if they're out there pushing video. They just basically are told, hey, I can go in here because it's a last mile connection. Now with this new ruling, I don't need to worry about the quality of my service being delivered and accessing that end user. This is going to play itself out over the next couple of years in courts. It's not going to stand the way it is, I think.
Yeah, I think that's a great point, Brad. It's if you look at what's happened over the last 5 years with last mile, it wasn't that long ago that everyone on the last mile just had dial-up connections. Now, then you move to DSL and broadband, and you had a whole nother, tranche of applications. Now it's relatively common for people to have webcams in their home that are on 24/7, that people are using to look at live video from anywhere in the world. And, you brought up the notion of IoT and M2M. Look, a lot of these industries are really taxing the network in terms of they have a great idea of how I can have, make up something, a live webcam in my refrigerator so that when I'm at Safeway, I can decide, what items I need and what items I don't need. And that, my refrigerator, my thermostat, and my garage door opener can all talk to each other. Right. So a lot of these are actually very interesting applications, but have impacts on the specifically the last mile, but the network in general that maybe haven't been thought through the way that they would be if they were delivered by the operator themselves.
Yeah.
Right. Because they're being developed by an application person who is simply running on top of the network. And so, regardless of whether you're pro or con, net neutrality, and I'm trying very hard to keep that argument under wraps right now. The important thing is to understand how those new applications will be brought to market, what kinds of impact they will have on the network, because it is relatively common today that, look, if you went and put in your home network, 5 different applications, all of which had real-time video feeds and real-time audio feeds, that could bring your last mile down to a halt.
Yeah, I completely agree with you, Dave, on that. And, IoT in general, you're going from a single-digit number of devices in a premise, a residence or something. You're talking about dozens of devices, right? And they'll be on-premise, network traffic, obviously, and then some sort of a real-time cloud layer is going to evolve, where this very recent state of these devices is going to get propagated up to these network applications. And then they're going to need, obviously, access so that they can provide kind of the cloud-based enhanced value that folks are expecting out of a true Internet of Things app, true smart connected product. I think fundamentally the vulnerability here on the last mile carrier is the lack of fundamental choices, right? At the end of the day, when you go market by market, MSA by MSA, there are very, very few options out there if you want true broadband. You're typically down to one service provider, maybe 2 if you're lucky, for most urban areas. And you can imagine what the rural situation's like. So the reality is they're going to need to keep building out this infrastructure. The cost per bit of delivering that last mile connectivity needs to keep dropping dramatically so that the financials make sense for them. And with this ruling, it clearly makes it more difficult for them to monetize investment. So it's not over yet, I'd say.
Well, what is it? Let's get back to the software development community. We talked about this clashing of the traditional telco with the over-the-top guys, and again, MDM and over the Internet of Things are bringing the groups together where they have to play well together. And again, you look at the FCC net neutrality ruling, they specifically, the Wall Street Journal referenced, Netflix having to connect with a Comcast.
Mm-hmm.
But what does it mean to the software developers? So you've got the C++ guys and you got the Ruby guys. How are they going to work together?
Brad, you want to take that?
Sure. When you sit down and Dave and I have both lived this over the last few years, right? I mean, all of the apps out there that people are using on their smartphones, how many of them were really developed and deployed by the folks that own the telecom infrastructure? I mean, you have to be honest about where the innovation is coming from. If I were a young developer now, I'm looking to my son, for example, who's in computer engineering, I would absolutely coach him, advise him to get into the application side of things, which by its very nature is not something that a typical telecom is involved in. So, and what the languages they need to learn, they need to be absolute experts on the JavaScript side of things. And then the way JavaScript is actually morphed out into all these various frameworks, including Angular and a bunch of others. Facebook's doing some amazing things with React.js. So that's absolutely fundamental. I would absolutely encourage them to get into embedded systems as well. So this whole blending of hardware and software, and especially embedded Linux, and not forgetting how to code C. And if they're going to do server side and enterprise focused apps, they got to do Java. That would be my
anything else?
Yeah, analytics, right? Everybody's talking about all this big data stuff. Big data by itself is worthless, but when you start applying analytics to it, that the real machine learning and stuff, you're going to need specialized tools for that. And R is the one that comes to mind as the kind of the optimized language that's most useful for data scientists to get in there and go off and running, as opposed to a traditional third generation language.
Yeah, no, I think Brad's right. Innovation has been driven by, either a large or small set of software development people who are making interesting applications. And the thing that I love about, net neutrality has its pros and cons and everything. The thing I love about net neutrality is making a platform where it's very easy to go drive and launch innovation and new applications. And for people who are getting into that, as Brad mentioned earlier in the segment, the world has evolved into serving up APIs. And you need to, a lot of those APIs are, Node.js based or JavaScript or other kinds of things. These are the technologies that programmers need in order to efficiently and easily bring new applications and new innovations to market. And I think that that's important. I will admit, I am a little bit of an old school guy. And so I do believe that there is usefulness in learning languages like C, understanding how memory allocation works under the covers, and because I think that when you don't understand that, it's easy to say, oh, the programming language will take care of memory leaks for me kinds of stuff. And that's not always true. And so I think that it's important to understand the fundamentals of how code actually works under the covers and the things that the compiler or the interpreter actually do for you at runtime. But in terms of languages that you need to understand, going into, a Facebook or going into a Google or doing your brand new startup kinds of stuff and going in and making a new application which is going to run over the top on this, next gen network kinds of stuff. I completely agree with Brad in terms of the languages and the skill sets that are required to do that.
Okay, well, jumping back into the telco camp, they've got these traditional BSS, OSS systems that are based largely on, frankly, antiquated technology. And they've got hundreds of millions of subscribers. They're provisioning. They've got policy and charging and billing and validation of who that person is, where they are. How are they moving to this new world of programming?
NFV, network functions. Yeah, network functions virtualization. That absolutely is kind of table stakes for them to go web scale and telco grade at the same time. So all of this OSS, BSS infrastructure that you mentioned This stuff is stable, it's reliable, it does exactly what they need to do operationally. They need to virtualize all that stuff according to the NFV standardization process it's going through. Once that's there, they overlay kind of the cloud management aspects of it. The elastic management, the being able to turn up instances of particular elements and stuff in an application deployment. All of that needs to happen, and sooner rather than later. Once they have that, then they have a telco operational environment that can scale to web levels, and that's a win. That's absolutely where they need to go.
Yeah, let's talk about elasticity for a second, because I think it's an important point. You know, the reason that the carriers have always been so focused on testing and achieving reliability before launching it in production is because of how these services were historically deployed, right? So in a model where the operator needs to go deploy big iron everywhere, lay out the software across the big iron, and when they have load spikes, ensure that they have enough metal and enough CPU capacity to handle those load spikes, they need to be very conservative in their approaches. And in a messaging system, for instance, that may only have its peak traffic once a year on Christmas Day, you need to have enough CPU power to handle that Christmas Day and deploy it, in the entire time. And so that's one of the reasons the traditional deployment methodology inside of an operator has not had the elasticity required in order to drive some of these new things that Brad has been talking to historically, right? Because, if all of a sudden the operator needs another 20% more CPU headroom, you're now talking at least days in terms of acquiring new hardware, installing it, bringing it up, and integrating it into your system. The great thing about virtualization and either the cloud or the hybrid cloud approaches that the operators are now taking is it does give them the opportunity to have an elastic model in terms of deployment of services, which does allow them to finally use some of these new techniques that operators like Google and Facebook and others have used from essentially day one of their deployments.
Mm-hmm. Well, virtualization offers the promise of lower cost of operation, but it really brings up the question of standards and open source. So maybe we could talk a little bit about the tension there. Carriers like standards, equipment manufacturers love standards, but in order for the carriers really to keep up with the price curve per bit, they have to adopt these lower cost software and lower cost server options. So where are we in that race to standards that are open source?
Go ahead, Dave.
No, go ahead, Brad.
I was just going to say, any service provider it's in their best interest, whether a NEP likes it or not, a network equipment provider, to encourage the use of open source. And I would just simply point people to LWM2M, the OMA's lightweight M2M standard, and all the work that's going on there. You've got Vodafone partnered with Eclipse on open source IoT. There's all these implementations of lightweight M2M clients and servers. They're free, they're open source, they're out there. And that's unprecedented in my book. I think that's pretty much the way everything is going to go. There'll be commoditized components that are useful to the network that are based on open source code. I think there's plenty of room for a NEP to add their unique value on top of that. It better be some pretty compelling intellectual property. But as long as they can do that, I think they can basically build a business from there. And then the other angle I think that they'll probably be approaching is one on services. They're going to focus on the expectations that the telcos have about how things need to be deployed and operated. Clearly, a NEP is best qualified to take that kind of approach and keep the operator comfortable. So, but the tech that they'll be deploying, it may not be their own, right? It may be a whole bunch of open source based components that they then turn around and basically put together, assemble, and then certify, and provide SLAs for.
Yeah, historically, the operators themselves and even the network equipment manufacturers have not been hugely pro open source, and one of the reasons for that is oftentimes the open source code was more of a reference model of how to go do it rather than something which would operate, quote unquote, at scale. And so you could go have an open source version of a web server, for example, which was perfectly fine for serving up, a certain transaction rate. But if you wanted something which was going to really push the envelope in terms of either 259s or web scale, you had to do something slightly different. And that was the IP advantage that some of these guys had. Increasingly, you're seeing open source solutions that actually have the right kind of scalability to compete in this kind of market. And increasingly, you're seeing operators be open to and actually encourage the use of open source for a variety of reasons. And I do agree with Brad that I think part of the secret sauce moving forward will be how you best integrate various pieces of open source where the uniqueness and the intellectual property is how those things are integrated, how those things are layered together, and how they're brought together to provide a complete solution.
Well, let's close by talking about some of the key trends that each of you are seeing. I know you're both looking at some new companies, new products. Where are you seeing opportunities, and then as you look to form these companies and launch new products, where are you looking for talent, the right software developers that can work on the new open source platforms, but have some understanding of what an application is going to do over an RF signal or over an RF network, or how's it going to perform if it's got to connect to a carrier platform?
Yeah. So as I look around, obviously one of the big areas of focus that I'm seeing lately is security. And we could have, as Brad mentioned earlier, we could have a whole session on security, but it's not just because of things like the Sony hack or other kinds of things. It's fundamental in the nature of all the new services that are coming about. If you take just, 60-second diversion and you think about garage door openers, for example, when the first garage door opener came out, it was a completely unsecure system that simply had a remote that sent a wireless signal to a box that opened your garage door. There was no security in it at all, but it was widely adopted because of the ease of use and the capabilities that it provided, and later security was added in. And you're seeing a similar model follow with, the notion of Internet of Things and all the new devices that you're going to have in your house. And wow, look at how great this new capability that I have is, but does it have the right level of security? Is it hackable? Can somebody really now infiltrate my refrigerator and make it, hotter than it should be, or all these different kinds of things. And so it's not just on, the network level, but on the device level. And, from a holistic level, how do you really provide security? And I'm seeing people take approaches of building higher fences. I'm seeing people take approaches of, well, let's assume that they get in and restrict what places people can access. I'm seeing security at the database level all the way up through the application and the network. And it's a really hot topic these days that everyone has new budget for, and I'm not exactly sure everyone understands how they're going to spend that budget.
Mm-hmm.
That's just absolutely brilliant. I totally agree with you, Dave, on the importance of security. It is grossly underserved right now. Everybody's rushing a lot of tech to market with inappropriate levels of security attention being paid to the code. Right? I mean, you've got these Wi-Fi power outlet adapters. About a year ago, they were completely hackable. So if you're going to take an embedded Linux distribution, you better know how to lock it down, right? And make sure you don't that you can't easily root it or do some little exploit on it and get root access pretty easily on stuff like that. Security is absolutely huge. I think another area also is that you see this proliferation, in environments where you have a half dozen devices today. Imagine those having 60 devices, 100 devices in them, right? Within just 2-3 years at scale. How does that get managed, right? So it's not about the device itself at that point. It's about kind of the gateway layer and that real-time cloud layer I mentioned earlier. All that stuff's got to evolve And if you grab some share in those particular spaces, that's huge opportunity, I think.
Yeah,
Well, gentlemen,
I completely agree. I completely agree, Brad. It's the sheer number of devices out there is growing astronomically. It was, there was a great 60 Minutes segment on about 2 weeks ago on hacking cars, and just the sheer number of computers that are inside a typical automobile today, I think would astound most people in terms of how many different points of entry there are and how many different computers there really are. And so, look, if you're, sitting there saying, well, what languages should I focus on and what areas should I become proficient in? You want to become proficient in understanding security and security threats. You want to become proficient in figuring out how you, handle systems that manage multiple, tens of hundreds of devices, in your home, in your automobile, all interconnected. I think that those are going to be incredibly valuable skill sets moving forward. And it's not the case that just because I use open source, it's provably more secure. You still need to have these skill sets so that you can understand where the holes are, where you need to beef that up yourself, or where the possible intrusion sections might be.
Yeah. Well, gentlemen, we are out of time. Brad, Dave, thanks for joining us today on this episode of Coders. We invite folks to join us for our HetNet show with Sean Kinney and our NFV SDN show with Dan Meyer. In 2 weeks, we're going to be having our next episode that's going to focus on actually API and API platforms. We've got a guest from Apogee that's going to be coming in. They were recently received another round of funding from Kleiner Perkins. So we're going to talk about that intersection of telco and over the top at the API layer. And gentlemen, I just can't thank you enough for joining us today. Have a good day.
Thank you.
Hey, thank you for having us, Jeff.
Bye now.